Welcome back to pattern questions. So this is the third one of the growing patterns, and we will be concentrating on triangle numbers or triangular numbers. The previous one is square numbers. Now we have triangle numbers, or another name is the sum of consecutive numbers. And then we will be focusing on the Gauss method, which I will explain a little bit more later. So why we call sum of consecutive numbers triangle numbers? First of all, let's recap what are consecutive numbers. This is consecutive number. Numbers that follow each other continuously. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are consecutive numbers. Previously, we looked at consecutive odd numbers. So then we have 1, 3, 5, 7, 9, and so on. So the sum of consecutive numbers basically means 1 plus 2 equals to 3, or 1 plus 2 plus 3 equals to 6, 1 plus 2 plus 3 plus 4 equals to 10, and so on. So the sum, meaning I add them all up, the consecutive numbers. So why we call these number the triangle number or triangular number? If I put them in a diagram, this is what it will look like. 1 obviously is just one dot. 1 plus 2, one dot plus another two dots here. If I join them up, it will look like a triangle. 1 plus 2 plus 3. 1 plus 2 plus 3. I will still get a triangle. 1 plus 2 plus 3 plus 4. I will still get a triangle, and so on. So now you know why we call these triangle numbers. Okay, the sum will form a triangle. Now that we know what are triangular numbers, you might think, how will this question look like in exam paper? Okay, one of them is the classic question of 1 plus 2 plus 3 plus 4 plus 5 all the way to plus 100. Okay, and then they ask you what is this sum? Or previously in PSLE, you have this handshake question, intersection question. For example, I give you these, imagine these are roads. How many intersections are there? How many junctions are there? The dots or boxes that stack up to form triangles. You can see this triangle. It may look like a triangle like this or a right angle triangle like this. So these are some of the examples that might appear in exam papers. So how do we solve this classic question first? Some of you might have solved this in previous years. And then the classic method is to pair the first and the last number together. Okay, so for example, 1 and 100, I pair them together. 2 and 99, I pair them together. So each of the pair will have the sum of 101. Then how many pairs will there be? So 100, I divide by 2, I will get 50 pairs. Each pair is 101, so 50 pairs, the answer will be 5050. But what if the question is like this? 1 plus 2 plus 3 plus 4 plus 5 all the way to plus 99 only. Then one pair, you will have 100, 1 plus 99, 2 plus 98, 3 plus 97, and so on. But how many pairs will there be? 99 divided by 2, would they have 50 pairs or 49 pairs or 49 and a half pairs? And then the question in the middle, the number in the middle, number 50, will they have a partner? So this is the problem for this method. It's not that it is wrong, it is still a good method, but it might be confusing for some people if the question give you something like this and then add up to odd numbers. Okay, the last number is odd numbers. So the problem with this method is, will the number in the middle have a partner to form a pair? And then what is this number in the middle? So that is not so clear cut for some people. So we come to this method called the Gauss method. Give you a very brief history of this guy over here, is the Gauss. So this guy, I won't attempt to pronounce his name correctly. Anyway, he is a German mathematician, died long time ago in 1855. But he's very famous because there's this story when he was in primary school about P2. His teacher asked his class to add all the numbers up from 1 to 100, like the previous question that I gave you. And then this teacher assumed that this question will occupy them for quite a while because they are only P2, 1 plus 2 equals to what? Then 1 plus 2 plus 3. But he was shocked that when this young Gauss, only after a few seconds, wrote down the answer 5050. The teacher couldn't understand how he calculated the sum so quickly in his head. But the 8-year-old Gauss pointed out that the problem is actually quite simple. So this is his method as he explained to the teacher. So now, since this is the question, he added another row of the same number but in reverse order. So similar to our first method, he paired them up. So 1 plus 100, 2 plus 99, 3 plus 98, and so on. So each pair will be 101. Then how many 101 would there be? There will be 100. Okay, there will be 100 groups of 101. So the answer will be 10,100. But the original questions has only one row of this. One row of this. So this one is 2 rows. This includes 2 rows. So he divided it by 2. 10,100 divided by 2 equals to 5,050. What if we change the question 1 plus 2 plus 3 all the way to plus 56? How will this work? Similarly, we add another row, but at the bottom in reverse order. Then we add them up. Each of them will add up to 57. And how many groups of 57 would there be? Will be 56 groups. So 56 times 57. Again, remember these include 2 rows of 1 plus 2 plus 3 plus 4 all the way to plus 56. So now we have to divide this by 2 to get our answer. So 57 times 56 divided by 2 equals to 1,596. What do you notice about these two numbers? 56 and 57. 57 is actually 56 plus 1, right? The previous question, 100 and 101. What do you notice? 101 is 100 plus 1. So, what if 1 plus 2 plus 3 all the way to plus n? It will be n plus 1 times n divided by 2. Now, let's apply this formula to this question. Okay, so now that we can see the last number is 260, meaning my n here is equals to 260. So we apply this 260 in our formula, n equals to 260. So 260 plus 1 times 260, then divide by 2. My answer will be 33,930. So just by remembering and understanding this formula, you will be able to solve triangular numbers questions quite quickly. So now you try. 1 plus 2 plus 3 all the way to plus 125. Take out a calculator. Maybe you want to hit the pause button now. Okay, let's review the solutions and answer. In this case, n equals to 125. So 125 times 126, because 125 plus 1 is 126, right? So this times this, 126 times 125, divided by 2, your answer will be 7,875. So now let's go back to this classic PSLE question, the handshake problem. So 20 people meet at a party. They all exchange handshakes. How many handshakes were exchanged? So it will be good. Okay, so you don't have to draw this table out. I draw it out just to illustrate to you how this is a triangular pattern question. So if there's only you, one person, obviously you don't shake hand with anybody. So there's no handshake. Okay, this is you. And then the next person comes in, then you shake hand with that person. So there's one handshake. Then one more person comes, you already shake hand with the second person, and then you shake hand with the third person, and then the second person shake hand with the third person. So now I will have 1, 2, 3 handshakes. Then the fourth person comes in, this one. So you go and shake hand with him. The second person also shake hand with him. Third person also shake hand with him. So add all the handshakes together is 1, 2, 3, 4, 5, 6. Okay, or if you write it down in pattern like this, it will be 1 plus 2 plus 3 equals to 6. So next one that comes in, what do you think we should write over here? Yes, 1 plus 2 plus 3 plus 4 equals to 10. So this is the one more person here. Add another 1, 2, 3, 4 handshakes. Add another 4 handshakes. So the next one will be 1 plus 3 plus 3 plus 4 plus 5, and so on. So now, what do you notice about the number of people and the last number in the equation? This is number of people, last number of the equation. 7 and 6, 8 and 7. So this is number of people minus 1, you will get the last number in the equation. So now, what if I ask you, how many handshakes are there in 20 people? 20 people, the last number will be 19, right? So you can apply the Gauss formula, the Gauss method. Okay. Gauss method, n plus 1 times n divided by 2. So in this case, n is 19. 19 plus 1 equals 20. 20 times 19 divided by 2 equals to 190 handshakes. So we look at this. This is my n. And then we can solve the question like this by applying the Gauss method. What if this is a big party? 230 people. How do we solve this? Again, 230 people. We know the relationship between number of people and the last number in the number of handshakes. So this one will be 229 because 230 minus 1. Then again, we apply the Gauss method, the formula. 229 plus 1 times 229 divided by 2 equals to 26,335 handshakes. If during exam time you forgot what is the Gauss method and you can't figure out the formula, another way, of course, is to use the systematic listing to find the number of handshake. Write it down in a table form. It can be horizontal like this or vertical, and then write down what is the pattern. +1, +2, +3, +4, and so on. So then if you systematically write it down, carefully type into your calculator, eventually you will get 190. So again, you must be patient, must be systematic, use the table to help you keep your working neat so that you can check for mistakes and pay attention when you add the number in your calculator. Okay, if you don't make mistake, you will get your answer if the question asks you for a small number like this. Okay, if the question asks you, like for example 230 people, it will be quite tedious and quite time consuming to keep adding in your calculator. Okay, sometimes you will see this kind of question in exam papers. So how do we solve this? Part A is quite simple. Figure number 12. How many dots are there? So if we systematically put things in a table, you should be able to see this is a triangular numbers. So instead of just writing 1, 3, 6, and so on, okay, if possible, write it down. This is 1, 1 plus 2, 1 plus 2 plus 3, and so on. So that you can spot this is a triangular number, and then you can apply the Gauss method. Okay, so last number is 12. 12 plus 1 equals 13. 13 times 12 equals to 156. 156 divided by 2, answer 78. So now the second part is quite tricky, but I don't think you will see many of this type of question in exam anymore. So anyway, so we write this down, 1540 equals to this formula here, and then since this is divided by 2, I move this to the left hand side, it will be times 2. So this will be equal to 3080. So how do we solve this? 3080 equals to n squared, n times n, plus another n. So we don't know how to solve this, but then this is very close to equals to n squared or n times n. So we try square root of 3080. Square root of 3080, you will get 55.5. Usually you will get a number with a decimal point. And this number is between the two whole number. So this one is between 55 and 56. So you try 55 times 56. Is it equals to 3080? So yes, it is. So the answer will be 55 because this is equal to n plus 1 times n. 56 equals to 55 plus 1. So the answer will be figure number 55.